So, in the concept of 3.3, the graphical representation of pair of linear equations, up to now we have solved 3 examples. So now, let us go back to the pairs of linear equations formed in example 1, example 2 and example 3 and note down what kind of pairs they are geometrically. Okay. So, in the example 1, so example 1 deals with the giant wheel and Hopla ride. So, in that we can frame equations as x minus 2y is equal to 0 and 3x plus 4y minus 20 equal to 0. And we can clearly observe that the graph which was formed by using these two equations, in that the two lines are intersect with each other. And in the second example, that is purchasing of pencils and erasers. So in this example 2, we can form two equations as 2x plus 3y minus 9 equal to 0 and 4x plus 6y minus 18 equal to 0. And while plotting these two in a graph, we can clearly see that these lines are coincident with each other. And in the third example, that is two rails cross each other or not, in that we can frame equations as x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. While plotting these two line equations, we can clearly see that these lines are said to be parallel. So now, let us now write down and compare the values of a1, b1, c1 and a1, a2, b2, c2, and we have to obtain a1 by a2, b1 by b2 and c1 by c2 in all three examples. Here, a1, b1, c1 and a2, b2, c2 denotes the coefficients of equations in the general form. So, for example, if it is considered the first equation, let it compared with the standard form of equation, that is a1x plus b1y plus c1 equal to 0. From that, we are getting a1 is equal to 1, b1 is equal to minus 2 and c1 is equal to 0. And if you consider it as an equation 2, then a2 plus a2x plus b2y plus c2 equal to 0. If you compare it with the standard form, we are getting a2 is equal to 3, b2 is equal to 4 and c2 is equal to minus 20. So similarly, if we calculate for all the equations, we are getting a1 by a2 for first example 1 is 1 by 3 and b1 by b2 is equal to minus 2 by 4 and c1 by c2 is equal to 0 by minus 20. So we can clearly see that a1 by a2 is not equal to b1 by b2. So that we can clearly say if a1 by a2 is not equal to b1 by b2, then the graphical representation of that particular equation is always an intersecting lines. Okay, so that exactly one solution, that is a unique solution, will appear for this type of linear equations. If the given equations, when we calculated a1 by a2 and b1 by b2 and c1 by c2, and if we observe that a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then the graphical representation of these two line equations must be in the form of coincident lines. That is, it has infinite many solutions. If the given equation, when we write in the format of a1 by a2, b1 by b2 and c1 by c2, if we found that a1 by a2 is equal to b1 by b2 but which is not equal to c1 by c2, then they are considered to be as parallel lines. If you plot the graphical representation for the pair of equations, we are getting parallel lines, so that there is no intersecting point, so there is no solution for the two lines. So these are the three conditions we have to keep in mind. Why? Because in the upcoming problems, they were asking to check whether the given equations are intersecting lines, are coincident lines, or parallel lines. Then we don't want to represent all the graphical process. Just we have to find a1 by a2, b1 by b2 and c1 by c2 values, and we want to see what is the relationship between them. If you find a1 by a2 which is not equal to b1 by b2, then we can clearly say that the two lines are intersecting lines. If a1 by a2 equal to b1 by b2 is equal to c1 by c2, then we can clearly say that these lines are coincident lines. And if a1 by a2 is equal to b1 by b2 but which is not equal to c1 by c2, then we can clearly say that these line equations are parallel lines. So these three conditions are kept in mind so that we can help in solving the upcoming problems very easy.